Hi guys, this is my YouTube channel, and today I am going to draw your attention towards the topic how to avoid creating latches in your code. Actually, it is very important to avoid latches in FPGA code for several reasons. First of all, we know that timing uncertainty is there, like static timing analysis. We have read about that we go with worst condition of timing and we should find and hope for the best. The difficulty in synthesis also is there, increased routing complexity is also there, and higher power consumption. The power optimization is needed, the power is consumed at a higher rate, so it is needed that we should avoid latches. And other is the better design practices. Actually, avoiding latches helps us create more predictable, reliable, and maintainable FPGA implementations. So this is the basic need to avoid latches, but performing all others, we should move towards how to avoid creating latches in your code. So what is a latch? We know that latch is a edge trigger device. So we have got it. This is the point that output is less when enable is low. If suppose the output is to be latched, it means that it is to be edge triggered. This means that it is the enable is low. If enable is high, then the output will show the value D. It means the enable is 1 and the output is D. When enable is 0, if suppose the enable is 0, the output will not change. It keeps its previous value. If suppose, like truth table, if suppose that the enable is 0 and we don't know about the D, so the Q is Q previous, the output is previous, and if enable is 1 and D is 0, then output is Q is 0. It means that if enable is 1, then the output Q will be the D itself. And if enable is 1 and if the D latch is also 1, it also provides the Q output as 1. It means that it will keep the previous condition if it is 0, otherwise it will keep the output D as it is. So moving ahead, we will find that how latches are created. So latches are created when you create a combinational condition. We know that combinational logic circuits and about the combinational conditions with an output that is not assigned under all possible input. We don't know that what is all about the possible input. We can't assign that output about under all possible inputs. So for latches, when latches are created, it is a process statement in VHDL and it is a always block in Verilog. So moving ahead, how a latch is created in VHDL? So if we know that it is a process statement in VHDL, so process I underscore data I underscore enable begin. If I underscore enable is equal to 1, then our O underscore latch is less than or equal to I underscore data, and if an end process. So it means that if enable condition is 1, it is defined, but no definition for enable is equal to 0 condition. So it is well known that if enable I is equal to if I enable is equal to 1, then output latch is less than or equal to input data, but there is no condition for the enable is equal to 0 condition in VHDL. But what about if the output latch O underscore latch is less than or equal to 0 1 0 1, it is about when I underscore select is equal to 0 0, else 0 1 1 1 when I underscore select is equal to 0 1. It means that the enable and the select line. About the select lines, if we are talking about the mux, we can go forward with this, that if it is 1, then it is this, otherwise this is else 1 1 1 when I underscore select is equal to 1 0. So when I underscore select is equal to 0 0, it is 1 0 1. If I underscore select is equal to 0 1, it is 1 1 1. If I underscore select is equal to 1 0, it is 1 1 1 1. And 4 times 1. So this is the output latch when the latches are created in VHDL. If the latches are created in Verilog, it is a always statement. So always at the rate I underscore select begin. If I underscore select is comparable to 2 dash b 0 0, output latch is less than equal to, or underscore latch is less than or equal to 4 dash b 0 1 0 1. Similarly, if I underscore select is comparable to 2 dash b01, output underscore latch is less than or equal to 4 dash b0111. Else if I underscore select is comparable to 2 dash b10, or underscore latch is less than or equal to 4 dash b111, and I underscore select is equal to 11 is not defined. I underscore select 11 here is not defined as it is in VHDL. So what it is needed, that if the I underscore select is, the select line is like 2 dash b00, it is 00, then the output latch is equal to 101. If it is 01, then it is 111. If it is 10, then 111. But select line for 11 is not defined. Okay, so moving ahead, we will find that, make sure that all to avoid latches, make sure that all of your if or when statements that are used in combinational process or always block have one last else statement to catch all missing conditions. So this is all for today. We will find it. So needed is that if your statement or when statement is here, combinational process or always blocks have one last else statement to catch all missing conditions. Okay, thanks everyone. We will learn together. Thank you.